Code please.
Welcome to Code Please. In this channel, I try to teach you a little bit about computer programming using the Elixir language. If you find this content useful, please consider subscribing and sharing with your friends. Now let's get into today's video. Hi there. Continuing our exploration of processes, concurrency, and fault tolerance in Elixir, let's implement a practical case where we use supervised processes to execute some work on the background and have it available to the entire application when we need it. If you followed along the previous videos, you might notice that manually launching all these processes can be a tedious process. So this time we will leverage an Elixir tool named Mix. Mix is Elixir's build tool. It allows us, among other things, to package our applications for deployment, run tests, or execute any other tasks we might want to run against our code, even custom tasks written by us. Let's start by creating a new Mix project and exploring what it's all about. For this, we will use the command line first and then explore the code inside the code editor named VS Code. So, to create a new Mix application, we can use the mix new command. And the application we're going to build is going to be basically a little program that is going to reach for a couple of sources and aggregate some information, some profile information about user. So one of the sources is going to be GitHub, and the way we can create our application is by using mix new, and let's call our application profiler. And what this does is create a new folder that contains a few files. And I'm going to explain what all of these files mean inside the code editor VS Code. Now, you could use any editor of your choice. You can even use Notepad or Sublime or whatever you want to open all these files and work on them. I just find that Visual Studio Code is an easier experience, so I'm going to use that. If you are interested in installing it, you can just Google for Visual Studio Code, and you can download the free version and install it. And once you install it and open it, you get something like this, where you can add a folder to it, and we are going to basically open our project. If I can remember where I have it. Let's see, dev, Elixir, and profiler. I'm just going to add the profiler. And immediately Visual Studio Code detects that this is an Elixir project and kind of splits this up and gives you nice icons here. So what Mix generated here was an initial module called profiler with a function that's called the load that just returns a world. This is just basic stuff. And then it also generates some tests for this. And we're going to talk about tests a little bit later, but not now. And then it generates a file called formatter that helps you basically format your files according to some rules on how to structure the code so it's more easily readable. There's also a git ignore file. This is a version control file that tells your version control tool what files to ignore. Git in this case. You don't really need to worry about these two for now. README is just a README for your project. You could adjust this, and if you push your project to GitHub, for instance, it's going to be like the front page of your project with all the information that you would want to write for people to be able to run your project. And then the most important file of all is the mix exs file, and this is where you actually declare your project for the beam. And so this project requires you to implement a couple of functions, namely project, application, and deps. Deps is where you define the dependencies of your application. If your application depends on external libraries, such as libraries to make HTTP requests or to parse some JSON data or XML or whatnot. Application is where you define what your application looks like, what it should start when it starts, like what kind of modules should it run. And in project is basically the declaration of your project, like the name, the version, the Elixir version that it needs to run, those sorts of things. And now if we want, we can just run our application, and it's not going to do anything for now because we're not telling it which code to run. The only thing it's going to instantiate is the logger but we could do like IEX minus S mix. And this is going to tell the interactive Elixir console that we are working with a mix project. And then it's just going to compile your application, generate your app, and start it up. Now it's not doing anything for now because we haven't specified anything, any entry points, any module as the entry point of the application, but we're going to do that really soon. So now we know how to create new applications using Mix and also how to run them from the command line. Let's implement our supervisor and the rest of the code now. Okay, so right off the bat, I know I'm going to need a couple of libraries. Namely, I'm going to need one library to do HTTP requests, and we're going to use HTTP Poison for that. And don't really mind about the syntax here. This is basically a tuple saying that we want the HTTP Poison library and the at least version 1.8 of that library. And I'm going to need another library called JSON to do some parsing of JSON data, because most of these APIs that I'm going to use, GitHub, they return data in the JSON format, so we need to parse that so we can handle it in our application. And now that we have the library specified here on the deps function, we can go ahead and on our command line, let me just close this, we can do something called mixdeps.get, and this is basically calling the deps task on mix, and the subtask is going to be get. So we're going to get the dependencies that we need, and we can see that it retrieved HTTP Poison and JSON into our app. So now with our dependencies defined, we can start actually building our application. And the way we're going to do this is, well, for one, we're going to tell our application which module to start. And so we're going to pass in a mod keyword here, where we're going to pass in profiler and no arguments. This is a typical way of specifying the module that you want to start on your application. You pass it the module and the arguments that you want to pass to the start function. So with this out of the way, we can use this profiler module that was created here. We can get rid of all this code that we don't need anymore. And we are going to tell it to use application. And this is how Mix will know that this module actually implements an application or the behavior of an application. And then we implement the def start function. We don't care about the type, and we don't really care about the args. We passed an empty list. And what we can do here is we're going to start a supervisor that is going to take care of three processes, basically. A manager process that will handle all the information about the profile, and a couple of processes that will retrieve information. One is going to retrieve information from GitHub and get some data out of there, and another one is going to get information from a funny API that I found that predicts the age of someone based on their name. And then both of these are going to aggregate this information and send it to the manager, and the manager will combine these two pieces of information together to mount a more complete profile about someone. So that's the idea for this sample app. So when starting up our application, basically what we want to do is start our supervisor that we're going to write in a second. And the way you start supervisors is a bit like you start agents and GenServers. You do start link, and let's give it a name. We're going to use the same name as the supervisor module. And this obviously is not going to do anything. It's actually complaining that the supervisor doesn't exist because we haven't written it yet. So let's write it. Supervisor.x, and inside this file here, we are going to define a module called profiler.supervisor. And in here, we are going to tell it to use supervisor. You can see the pattern here. Every time you want to implement some behavior from some base Elixir module, you use the use keyword. And then we're going to define a start link function that we called from our application. It's going to accept some options, and it's basically going to say supervisor.start link, and we're going to start ourselves with OK as the initial params and opts. And if you remember, when we named our GenServers explicitly, we used these opts here. We passed in name and the name that we wanted to give our GenServer. In this case, it's the same, but the name is coming from the outside, from the profiler. We're passing it in here. So it's going to end up defining the supervisor, named supervisor, so to speak. And for completion, we're going to just go and write here supervisor, if I can type, start link, one argument, just so we can keep track of the order in which the application starts and all the processes start running. And then we need to implement an init function for the supervisor, which accepts the initial arguments that we wanted to pass. Since we passed OK here, we can pass here. We could pass it anything, it doesn't really matter, but let's just use OK for now. Then I'm going to do inspect and supervisor. Why do I keep writing supervisor? Init/1. And here we're going to tell our supervisor which children processes to spawn. And after that, we're just going to call supervisor.init with the children, and we're going to pass it a strategy. Don't really worry about the strategies. You can read about it in the documentation, but basically we're going to say 1 for 1, meaning that anytime one of the children processes crashes, it will respawn a new one in its place. So and let's start by implementing our manager, and we're going to pass it in a name as well, and profiler.manager, and this is going to be our only child for now. Okay, so we need to implement this manager, so let's create a new file, and this is going to be a slightly larger bit of code, so I'm just going to copy paste it in so we don't waste too much time. But basically it's a GenServer. This is a module attribute. This is a macro that gets replaced in compile time, so it's going to replace wherever you put @me in the code here, and this could be anything. It's going to replace it with __ module when it compiles the module. So it's just a short, so we don't have to write __ module everywhere. But anyways, it could be, actually we could do this and it would still work. Yeah, so notable things: we have a start link function, as all GenServers require. We are starting a GenServer with OK passed into the init, and we are merging whatever options come in with our name. Actually, we didn't need to do this because we're implementing here, we're already passing the name here, so we could just as well pass in opts here. And now we have a client-side function called profile that basically makes a GenServer call to the server part of this GenServer, asking for the profile, and it's handled here on the handle call. It just returns basically the state that it has, and it's initializing with an empty state. We've seen this before in previous videos. And there's another cast that can be called, which accepts update and merge and data. And this is going to be called by our child processes that actually do the work. So the GitHub worker and the age verification or age estimation worker, both are going to call update and merge, and basically merge whatever state exists on the manager with their own data. So we end up with a kind of a mix of the two profiles into one inside our manager. And that's basically exactly what we want. And then eventually we just implement the catch-all handle info function, because this is a GenServer and we never know what messages can be sent to this process, and we don't really want it to crash when it cannot handle any a certain message. So we just let it pass for any other message that we don't care about. If we start our application now by using IEX -s mix, it's going to compile our code because we have new dependencies. It's going to recompile a bunch of things, and eventually it starts our application. And we can see from the IO inspects that we put in, first it starts the supervisor, then it inits the supervisor, then the supervisor is actually starting the manager and initting the manager. So we should have two processes, or more than two processes actually running right now. If we run the observer.start, we can take a look at applications now instead of just processes, and we can see that we have our profiler application. And if we click on it, we have a couple of processes that are handled by the virtual machine. Then we have our supervisor here, and we can see the ancestor trees and state and all of that. And then we can see our manager here. And if we take a look at, for instance, the ancestors list on the manager says it's basically a child of the supervisor. And the state right now, it's an empty state because we started with an empty state. So that's all fine and good, but what about actually doing some work? Okay, so we are going to want to go to GitHub first, and in order to do that, we're going to go to our supervisor, and we're going to add a new child here. And we can just copy paste this one, and let's name it GitHub worker. And what this worker process is going to do is periodically go to GitHub and retrieve my profile information, which is actually publicly accessible information. It's an open API in that part. So we can just create a new file called GitHub worker, and I am going to copy paste the usual GenServer part of the GenServer. Again, I don't need to do this because I'm already doing it here. And let's also put @me here just because. So one thing the GitHub worker is doing is when it inits itself, after 1 second, it's asking itself to refresh. So it's sending a message to itself. So it calls this refresh function on the server part. And finally, we also want a catch-all, because this is a GenServer again, we want a catch-all. And now we need to implement this refresh function. So let's see what it's going to do. It's an implementation, it's a handle info. So we need to listen to refresh. We're going to receive the state. We don't really care about the previous state because we're going to be updating the state of this GenServer every time we do a call to GitHub. But I guess we want to inspect this so we know that it's actually running. And now the way you use HTTP poison, it's fairly simple. You just need to start it, and then we can do HTTP poison.get. And this is actually making an HTTP GET request to some server. In this case, it's going to be https:/api.github.com/users/nuzo, which is my user on GitHub. And this returns a HTTP poison response with some data inside it. And we are going to pattern match this to get the body of the response. And don't worry too much about it, but an HTTP response usually has some header information, some body, some params, there's a bunch of data in there. We're only interested in the body for now. And the body is going to come out as a JSON string. So we need to parse it, and that's why we need the JSON library here. So we need to decode it, this body. And then in the response, we should have something similar to a map in Elixir with a bunch of data coming from GitHub. And we're going to update our state by map.taking from the response some fields. So for now, let's take out the name, blog URL, and the avatar URL. And then we can, well, for starters, we need to store that in our state. We don't need to because we're gonna update it anyways every time, but in any case. And we also don't want to do this again after a certain amount of time. So we're going to send a message to ourselves, refresh after, say, 10 seconds, so we don't cause too much traffic for GitHub and they start blocking us or something like that. And another thing we want to do is update this information on the manager, because we want the manager to be the aggregator of the profile information. So we're just going to do GenServer.cast profiler.manager, because we know this is the name. We don't need to use the PID, and we need to match the signature of the function on the handle info. So it's going to be something like this, and the new state. And what this is going to do is, going back to the manager, it's going to call this on the process, and it's going to match against this, and then it's going to merge the manager state with the data that we are sending in, which is the GitHub data. And so if we run this, we should see some more things. For one, we see that the GitHub worker just retrieved some information. And if we wait about 10 seconds, we should see another call exactly like this. There we go. And now one thing we can do is GenServer.call on the profiler.manager. Don't worry about this. If we ask for the profile, we actually get the information that we retrieved from the GitHub. That's cool. And if we take a look at the observer, we can see in our application that we now have a GitHub worker here as well. And we can actually see the state that it's returning. And if we crash this process now, since it lives under a supervisor, and this is the cool part about Elixir, if we kill this process, we killed it, and it just relived itself again because it's under a supervisor. And this is really, really powerful for fault tolerance and recovery in your application. You don't need to worry about it. It's just the virtual machine just takes care about everything. So let's finalize this by implementing the last one. We're going to do another worker. This time we can go to our supervisor. We can duplicate it here, and let's call it, I don't know, age worker or something like that. I don't really have a good name for this other than that. So let's just implement age worker.x. And I think I'm just going to copy paste the entire GitHub worker because we already have all the main parts that we need here. Just going to do age worker, and then this guy is also going to call update and merge on the profile manager. The only difference is we're not going to call this anymore. And also another thing that we're going to do, since I could not get this to work with HTTP Poison for some reason, I kept getting bad requests on this API that I was using. So we're going to try to do this in a slightly different way. Instead of using HTTP Poison, we are actually going to use another HTTP client called Tesla. And we just add our dependency here. That's all we need to do. And then we just need to do mix deps.get again. And we should get Tesla in there. And Tesla works in a slightly different way than HTTP Poison. So instead of explicitly doing the request here inside our age worker, what we're going to do is we're going to create a module that wraps all the calls that we would do to this age API. So we're just going to create a new module named ageAPI.x. And inside here, I'm just going to copy paste and I'll explain the code. But basically, we tell it to use Tesla, which is implementing the behavior Tesla. And then we can add some plugs like setting the base URL for this API and also stating that this API also actually accepts and returns the JSON format. And then we can create our costume functions. In this case, I'm going to create a function that is called age, and I pass it in a name. And then what this will do, if I call the base callback from Tesla get, it will take the base URL and append question mark name equals name. This is just string interpolation in a different format. So it will actually call all of this and then question mark name equals Pedro in this case. So it's a different way of doing things than HTTP Poison, but it's also very interesting because if later, say, you want to change the way in which you call this age API, you would only need to change this module, and you would not need to like change any of the signatures. So you could still have this age function accepting your name, but instead of get from the Tesla library, you could, for instance, use HTTP Poison in here. Why not? And kind of shields you from having to do bigger changes further down the line in your code. So now what we can do here is, instead of doing this, we can just do profiler.age API. I think I named it that, didn't I? Yes, I did. And then we can call age for Pedro. And I think this is going to return, actually, you know what? We can do a test here. I can just do curl https api.agify.io where name equals Pedro. And if I call this, I can see that they return JSON and they return a map with the key name, age, and count. So let's just take age from here. So take from our response age, and I'm not sure this is going to work, but we can see. So in order to debug this a little bit easier, I'm going to inspect whatever data is coming into the update and merge. And if we run this, we should be able to see what each worker is trying to merge into. And they are basically merging nothing. So let's see what's going on here. So I figured out why the manager returned the empty state. It was a couple of things. The first was that the GitHub API has a limit of 60 requests per hour for the free tier if you make a request that is not authenticated, which is the case that we're doing here. And it was basically just returning an empty response at that time. And also our age worker, we were not parsing the response correctly, so Tesla returns a struct that has a body inside, and we were missing this pattern match here, so we could return the body. And actually Tesla, since we on our age API module, we define this as Tesla middleware JSON. Actually Tesla behind the scenes does the decoding for us, so we don't need to do this part here where we decode the body. We can just plainly pattern match the body, and we know that it's a map already. So, and from this map we take the age key, and then we can do update and merge on our manager. And I also took the chance to change this signature here to include the caller, so we could on the manager say, okay, this caller wants to merge this data into the state, and we just need to do the appropriate change here, passing me on the call and also on the age worker. So now hopefully if we do IEX-S mix, we should see everything starting up. Both workers work, and we can see that Elixir profiler GitHub worker wants to merge the avatar, the blog, and the name, and then the age worker wants to merge the age. It guesstimated that I am 58. It's not true. I'm much younger than that. So if we call profiler.manager.profile, now we get a fully merged map with these three coming from GitHub and this one coming from the age API. So as you can see, we managed to accomplish pretty much with what we did with GenServers only on the previous video, but this time, since we implemented those with the supervisor in front, whenever one of the processes crashes, the supervisor automatically reinstantiates one of those processes, and they perform their job. And this is very, very good for error recovery. You are the assurance that your project is going to run potentially forever. So that's it for this video. I hope you enjoyed it. The next 2 weeks I will be on vacation, so expect a new video in September, where we will probably start looking into developing websites using the Phoenix Web Framework. So until then, cheers! If you like this video, please consider subscribing and liking and sharing with your friends. It really helps the channel to grow. Thank you.